Hello, everyone. I'm Alan Willard, Senior Technical Artist and Designer at Epic. I'm also part of the Developer Relations team, so I do a lot of training, occasional live streams like this. And what I'm going to be talking about today is using blueprints in conjunction with effects to do complex or interactive behaviors. Things like, based on where the blueprint is in the world, it does something different. So to start with, I'm going to start creating a little bit of content here. So let's start with a material effect. And we'll call this glow proximity. So this is going to have something very simple. It's just going to be a simple vector parameter, which we'll call color, and a scalar parameter called brightness. And we will multiply these two together, and they'll go into the emissive channel. So now my color is modified by my brightness, and then that becomes the illumination that you'll eventually see. And we'll pick a default color of, say, a saturated orange, and a default brightness of 1. So now we've got this yellow sphere. So on the blueprint side of things, we'll create a new blueprint based off of actor. We'll call it player proximity. And inside this blueprint, I'm going to create a new sphere component, or a new static mesh component, and I'm going to find a sphere here. Filter for static meshes, and this will be fine. The material sphere will work just fine. And there we go. Get rid of that component. Now, material sphere is just the default object we use in the material editor to preview anything on. I'll go back to my demo content, and I'm going to apply this material to my static mesh. So now I should get the same yellow glow. Now, in the construction script, we're going to do the setup, and this is where we're going to define the material properties in the blueprint so that we can interact with it. So I'm going to control left-click and drag the sphere into play, and then I'm going to create a dynamic material instance. And what this is going to do is allow us to interact with this material over the lifetime of the blueprint. By default, it's using index 0, which is the one that I assigned the glow material to, and I'm going to promote the result of this into a glow material variable. So by typing in the name, I can now refer to it anywhere I want. So this will allow me to work with this glow material whenever I choose. Going into my event graph is where I'll do things based on what's happening during the game. I'm also going to create a couple of variables here. So we'll create one that's a float called distance, and one that's another float called max intensity. So the distance, I'm going to use that to set my limits for how far away am I going to sense the player, and then the max intensity is going to be how bright am I going to get based on that. So I'm going to, on begin play, set up a timer, and I'm going to call this timer, oops, wrong one. Just check, and we'll say this timer is every 10th of a second, and it loops. So what this timer is doing is it's allowing me to call an event that I'll define in a second, and because it's set to looping with a 1/10 of a time, every 10th of a second it's going to re-execute this event. So we'll create a custom event, and we'll call this check. So now once the game begins, it'll set up this timer. This timer will execute this check event repeatedly, and I'm going to get the player We'll just get the one at index 0. And we are going to get self, because I want to know something about these two. So we'll get the actor location for self, which should give me a position, and then we're going to get actor location again for the player. So this is giving me the location of the blueprint in the world and the location of the player. And then I can do a length of the vector. Oops, that's not what I want. I'm going to subtract these two vectors, which will give me the vector between them, and then get the vector length. So now this should return a value that changes based on how far from the player this blueprint is in the world. And just to see if this works, we'll add in a print string, and by dragging these two together, this does what we call automatic coercion. It takes the float and converts it into a string, because that's what this property requires. We'll compile it, and let's modify our world a bit. We don't need these things. I'm just going to drop my player proximity object in here. And based on my distance to that object, the number that's streaming in the top left corner changes. So it's giving me the distance from me to that object. So now that I have that, I can use this information to give myself some control over what's going on. So in this case, I'm going to get rid of this print because I no longer need it now that I've verified what I wanted to know. And I'm going to use my max distance, or my distance, to find out whether or not this range is within the limits that I want. So we're going to map this float to a distance of, let's say, we'll set the default for this distance to something like 800. So it's going to take whatever my value is and go from 0 to 800 will be 0 to 1. Now this is going to end up, if I'm more than 800 units away, I'll get a return of 1. If I'm at 0, I'll get 0. So it normalizes that range in a way that's useful. And then I'm going to use this to lerp, or linearly interpolate, from 0 to whatever my max intensity is. Again, control drag gives me that. So now, whenever my distance result is 1, I will be at max intensity, and otherwise I'll be at 0, or some range between. So bringing my glow material in, I'm going to set a scalar parameter, and back in my material, remember we have this brightness parameter, and that's what we're going to drive. So we will give it a parameter name of brightness, drive the brightness based on my lerp result, and now I'm going to implement my check in. It looks like I got something wrong. Hey, it happens. Open up and see. Let's see what we're getting. A great way of finding out what's not quite working right is by printing results. So, looking at it, I figured out what's wrong. I never set a max intensity of anything but 0. So let's set this default to 3, and I'll bet you if we just play now, there we go. So now, based on my distance to that orb, it's going from 0 to 1. or 0 to 3 because my my max intensity is 3. So this is one way that you can set up a parameter-based interaction with the world. So wherever the player is in the world, this object will get brighter or darker. So you can do something like inventory hints, like here's something that the player needs to pick up or interact with. You can turn that on so the player can see it more easily. I could easily invert this as well. So if I wanted it to get brighter as I get close to it instead of darker. So now as I get away, anything more than 800 units away and it's completely dark. So from a material perspective, this is one of the simpler ways to drive behavior. Do a simple check within the blueprint to compare two objects and use that result to drive something. We had some questions coming in. So let's see. The distance material node has some very odd behavior on varying Android mobile devices. Is that a bug or just how it goes on mobile? It's an excellent question, and I don't know. I haven't done any Android development personally, and in the mobile development that I've done, I haven't used the distance node, so I haven't seen anything going on. If you do see it, I would suggest if you can put a repro case on Answer Hub or something like that, and we'll see if somebody can take a look. Let's see, the vector length, is it from the center of the object to the player or from the edge of the sphere? It's from the center. It's basically just using the object's position in world space, which means it has no knowledge of the radius of the sphere. You could, if you know the radius, and this would only work for a sphere, but if you know the radius of the sphere, you could subtract that radius from your distance value to get the approximate surface of the sphere. So if I were to take, assuming that the sphere it's probably something like 100, can take a look here. Yeah, it's 100 units across, which means it has a radius of 50. If I then subtracted 50 from my vector length, I'm now essentially moving my result closer to the player by 50 units. So now I should reach approximate maximum intensity as I get close to the surface instead of needing to interpenetrate the sphere. Now this is slightly incorrect again because my player's capsule moves my contact point further out. So if I knew the radius of the player capsule, I could adjust for that as well. But for something like this, it's an appropriate enough approximation. Someone asked, is there a performance difference between string-based timers versus delegate timers? I have no idea. It's an excellent question for an engineer, of which I am not one. They also asked, can we create delegates yet? Dragging that delegate wire against half the blueprint is meh. Again, not sure. I just wonder if there's a lookup table query or lookup table query every call or something like that. Again, not an engineer. My apologies. It's an excellent question for us to follow up on later. Somebody asked, how do you control material functions like a dissolve effect and have them occur when you want them to? So there's a couple different ways you would dissolve. You could do an object dissolving in space, like I'm no longer want to see it either because it's been destroyed or whatever. And that you could do very simply based on an event. So inside of my material, and we'll just overload the material I already created. So right now this is an opaque lit material. If I change this to masked and use my dither temporal anti-aliasing, this will leverage the temporal anti-aliasing's per frame jitter to let us have a mask that blends out. If you think of it as having less and less sand on a surface, because the temporal anti-aliasing averages the results of any given pixel. As your mask changes from frame to frame, it averages basically the on and off bits of the mask. So you end up with an approximate result. Just wiring this up, and you can already see the dither pattern occurring here, the little sparkles. If I then set a variable, let's see, let's call it threshold, and feed it into the alpha threshold. At 0, it's almost completely transparent. We'll get rid of the blueprint because I'm going to do this directly on the sphere. So I'm going to create a material instance from this so I can adjust that property very quickly. I'll drag it onto my sphere. And now, as I increase my threshold, you can see it kind of fade in. And then you could drive this in your blueprint in a very similar fashion. The slower you do it, the more approximate time, or the more time the temporal anti-aliasing has to move the pixels' positions around, so you'll get a smoother result. You'll notice there are some artifacts with it every time I move, because it's allowing a percentage of the other side through. The approximation takes longer to kind of converge on the final result. So this is more likely to cause smearing or blurring artifacts, but it can be done. Now, if you're doing something where you want a particular dither pattern, you could, instead of using the dither temporal anti-aliasing, you could find, for example, a noise texture. So as a quick example, this is just a Perlin noise texture sample, nothing too terribly fancy. If I take my texture coordinate and say this is going to tile 8 times, just as an example, I'm going to feed that into a panner and set the panner's speed to be fairly high. I can do pretty much the same thing. You could do a whole lot more math to have this be more unique. I'm just panning it in a particular direction. So you can see if I wanted a particular pattern to have it dither out by, I could use a texture mask to do that and just do some of the very fast motion in my shader rather than relying on the dither pattern. So that lets me have this very particular etching effect, if that's what I'm looking for. So one of the other parts of effects, obviously, oops, get rid of the sun instead, is particle systems. So I'll create a real quick particle system. Call it PFX example. And let's just change the location, give it a sphere module, so we're getting particles spawning in approximately a ball. We'll increase the spawn rate slightly. And let's say we want to adjust something like the velocity. Right now the velocity defaults to a uniform initial velocity that just gets the particles moving in an interesting way. If we do it based on particle parameter, this is where we can start having some influence on what's going on. So we'll call this velocity, and we'll set the parameter mode specifically for this. Now, much the same way that the clamp or the clamped map worked in the blueprint before, where we feed it a value and we tell it what we want the output range to be, by default particle parameters work very, very similar. The input is what the min and max is what range do you expect the value to come in as, and the output is what do you want that to actually do to this module. So if you had very small values, say 0 to 1 in each axis, then your min input would be that. But if you wanted to amplify that up so that a value of 0.5 spit out particles at 500 units per second for velocity, then you'd set your max output to 1,000. So a value of 0 would be 0 across the board, but a value of 0.5 as an input would be 500 output. And you can map negative values. So if you wanted to have 0 to 1 be negative 500 or positive 500, you could do that very easily. And that's the normal parameter mode here. Changing this to be abs would be always positive values coming out. And direct is it ignores the mapping and just picks whatever you feed in to the parameter. So if I tell the parameter I want 0.2, 0.2, 500, that's the velocity that I'll get out. And then the constant value at the bottom is essentially the default or preview value. So if I set this to be 50, 50, I'll move at 50 units per second along X and Y. So if I just drop this in my scene, you'll see that happening. It's moving at a 45-degree angle relative to the ground plane. But because I've parameterized this, I can now drive this inside of the particle system, or inside of the blueprint. So we'll go back into our player proximity, and here we're going to dump the material sphere, and instead we're going to add this particle system. And go back into our construction script because this is no longer valid. And because there's nothing we really need to set up inside the construction script, we're going to go back to the event graph and get rid of some of this core behavior, but not all of it. We just don't need anything that directly refers to the material because we've no longer created that. So now we'll go in and take our particle example, and we're going to set a vector parameter, and we're going to call this velocity. Now, what I'm going to do is I'm going to have this move along Z. The closer the player is to the particle system, the more it moves directly up. Let me make sure my my velocity check is still good. Yep. And then, so this is going to go from 0 to our max intensity. Our max intensity is a little high, so let's, or a little low, so let's make this 150. And because I want this on Z, I'm going to make a vector by dragging off of my parameter. And I'm going to use the result as just the Z channel of my RGB, or my XYZ value. So now, in theory, what will happen is it'll check to see how close I am to the particle system or to the blueprint. The closer I am, the more intense it should move along the Z-axis. And let's make sure I didn't miss something, because it does happen. Oh, let me make sure that my parameters are exposed. Grab this and put it somewhere a little bigger. There we go. We have to expose the parameter. So there's velocity. Still not getting what I expect. So we go back in and we start doing some I love having things not work right. It's exactly what I was hoping for.
That's how you teach how to debug.
Yes, Shelly just said it's how I teach how to debug. I have no idea if people can actually hear her.
They can't hear me.
They can? Ooh.
No, they cannot hear
Oh, they cannot hear her. Good. Conversations that nobody can hear. That's my favorite kind. All right, so we'll go in and we'll print this vector again. or this value, and we'll make sure that I'm still getting a, and I'm not. Hey, guess what? If you don't actually place the blueprint that you're looking at, if you just place the particle system itself, none of your blueprint code really matters. So let's go ahead and place the blueprint that I created, and let's see what happens when I play it now. Hey, look, it actually works. The closer I get to the particle system, the slower the particles move up. As I get further away, they move more quickly. What do you know? That works so much better when you actually use the code that you've written versus just running a particle system that does nothing of particular use. So I'm going to get rid of the print because I no longer need it. That's the wonderful thing about blueprints. They look great, and then you realize you're not actually using them, and they don't do anything if you don't place them in the world. So my blueprint is working as I get closer to the particle system. The particles change velocity out to my maximum. Now, because of the way that variables work in a blueprint, I'm by default setting these values. Whatever I set here is what it uses. If I expose these parameters by saying, giving them a tooltip, max distance to check for, and max intensity is total velocity to apply at max distance. So now the blueprint that I placed in the world, when I select it, I now have these values. So if I want to say my max distance is 100, but my max velocity is 10, I'm going to get a different result as I walk up. So if I get really close, they start to drift up, but as I move away, they slow down. Or I can set it to be more intense. So now I have a very, very close range. As I get close, they go very quickly. So if you wanted to have something where, say, for example, I push things away from me based on my distance, you can do that quite easily. In your blueprint, for example, right now I'm explicitly saying whatever my distance is, that's what drives my velocity. But if instead, let's say I take my my vector here, my distance from me to the player, and I'm going to use that instead. So I'm going to LORP vector based off of my map range. We'll move the max intensity off for right now. And we're going to take this and hook it in. So now I'm taking the vector from me to the thing and saying that will become my velocity as I get closer or further away. Just as a test, you can see wherever I move, the particles always move away from me. And if I reverse this vector, they'll always move towards me. So you can easily get something where the particles try to get away from me based on player proximity. So this is a great way to do something that interacts with the player in an interesting way, whether it's because I am wind and therefore I push the particles away, or if you want something that appears to try to escape from the player because I'm chasing away fireflies or something like that. It's pretty easy to set up. Now, obviously, you can combine these things as well. So I could do proximity checks to do the glow and have things scatter off. So if you do the I imagine I'm wind thing and you want to have that glowing sphere, I can add my static mesh back in. And find my material. So now I've got both the static mesh and the particles, and they're about the same radius. I'll go back into my particle system and set this to be surface only. So now my particles only spawn on the skin of the sphere. And we'll zero out the default velocities. So now I have a ball of particles that's approximately the same size as the orb that I've got in the center. I'll modify my glow behavior to be just the opacity by setting it to be back to opaque. So we'll set up some of the original behavior inside of my blueprint. So we'll go into the construction script and drop in my material sphere. Create a dynamic material instance, hook it back up. I didn't delete that material variable, so I'll just hook that back up by Alt left click and dragging, which gives me a set node instead of a get. And then back in my event graph, I'm going to use the same lerp. And set the max intensity back to 3. And then getting my material. I'm going to set the scalar parameter. And then I'll drop this in the chain. So now I should be doing both things at once. There. So every time my check executes, it will set the velocity with the particle system and also the brightness for the material on the sphere. It would help to set the material on the sphere to be the correct one. So we'll do that real quick. There we go. Well, it's certainly doing something. I suppose setting my max intensity in the blueprint itself, placed in the world, would help. So there we go. Now my particles are chasing away from me. As I get closer to the sphere, it gets darker. Let's flip that around a little bit and set the particles to get, or the surface to get brighter as I get closer. So now it looks like as I get closer to the surface, the particles scatter away. And we'll increase this range a bit. So now the particles, when the orb is dark, the particles are just spawning at the surface and not doing a whole lot. As the surface gets hotter based on my proximity, the particles will start to run away. And of course we can interact with this a little bit as well. We can get a random vector, multiply it by, yeah, that'll work. Multiply it by a float, and we'll say 10. And we'll add these two vectors together. So now what I'm doing is I'm going to add some noise to the motion of the particle system. Now, because I'm doing this at the system level and not the individual particles, it's going to cause the particles as they get spawned to have some chaotic velocities. But they won't change. There we go. So now as I'm far away, no real motion. The closer I get, the particles spawn and move around at different velocities. There. So they go dormant when I'm far away, and they get very noisy and scatter when I get close. So these are the kind of things that we can do either for level effects, where you just want a vent that blows smoke that gets kind of perturbed when the player gets close to give some additional level of detail. Or you might do something where you have simple proximity for the player coming up to a decorative console and you see details pop up on the console that weren't there before. This can also be really useful for doing simple LOD. Is the player close enough to see something well? If he is, then you spawn more effects or you change the material, things like that. So wouldn't this be a lot easier and simple to do with material, world position minus camera position? Isn't this promoting bad practices? If all I was doing was brightening a material, yes, this would be an excessive way to do that. However, when you're looking at it from a system point of view, when I want to build something that uses the same data to drive multiple things, it becomes more efficient to do it in a different way. Could that distance trick control the morph value between various mesh morph shapes? Again, yes, you could do that, and you could do that inside of the material itself. So if you just want a distance check based on either pixel depth versus camera position, you can do it that way. What's the best way to create a rain effect using a material effect or particle system? It depends on what kind of rain effect you're talking about. If you just want rain around the player, where it's a world-based thing, then you could simple rain. Do something where you have an initial location that is, let's give ourselves a nice big box. And we'll change the initial velocity to be mostly down. And we'll increase the spawn rate so we actually see something. So this is just a very, very simple rain from the sky. You could do a simple on collision. For something like rain where you want it to be localized to the player, one thing we've done in the past is just attach it to the player so that as the player moves around the world, you're spawning a small amount of rain that moves with the player, but it doesn't move the individual raindrops at the player. So you're basically just spawning rain near the player that doesn't necessarily fill the entire world. And then you can, if you use GPU particle systems, you could do some very cheap scene collision to kill them off so that your rain doesn't penetrate objects that you're looking at, things like that. If you're talking about doing something more like raindrops accumulating on the camera, to do that very well, you need an actual accumulation buffer that isn't something I can access directly. We've done it with particle systems that are camera facing, where we have distortion droplets that appear. They're fixed to the camera. So basically in game code, we look to see, is the player somewhere that there should be rain? Is the player looking more than, say, 30 degrees from the ground plane up? If so, then we spawn particles on the camera based on that. And again, it's something you could do in blueprints pretty easily by looking at the vector of the current camera, and then also doing a check to see, am I in a particular kind of volume? It would take a little longer to build that in here than I have time for, but as kind of a general idea of how you do it, that would be what I would be looking at. Can I use dither temporal anti-aliasing in a precise direction to achieve a dissolve effect from bottom to top? Not as is, but I suppose you could if you also modulated it with a mask. So your dither temporal anti-aliasing basically fed into a gradient that determined where in space that happen. There's probably a better way of doing it by doing it in your own material construct instead of trying to do it by overloading the dither tempo anti-aliasing. It's always a problem if your UV coordinates are mapped in such a way that you get a good bottom to top. It makes it much easier. We've done the same kind of thing using texture mask that's kind of rendered to texture from a gradient mapped on, or doing it in vertex color, but it is possible. How limited is material use in UMG? Last I checked, and I haven't done anything in UMG in a bit, you have material properties but no lighting. So the things that you can do faked lighting using just material parameters and kind of building your own vector for what direction the light comes from, but you do have access to a lot of the other material. Basically anything you could do that would appear in an unlit emissive material you can do. I almost never use make vector. I usually right-click the pins and split them. Is that good, bad, or just preference? It's just preference. When the vectors first went in, there was no way of splitting the pins, so make vector is just what I've been using for quite a while. Can you use this with orbit to increase the spaz behavior? Yes, though not every node, especially when you start getting into GPU particles. Not every module has the same type of distributions. So you can see if it says distribution, most times you can pick a particle parameter and drive it that way. But if I convert this to GPU, and start looking at things like the way acceleration is done in a GPU particle system, it's not a distribution like that. You can't set all of those values. So it's important to note when you first begin working in your particle system like this, which type of particle system is it? For example, now that it's a GPU particle system, it still does everything that was there before because the engineers specifically implemented the way those distributions worked on GPU systems. But if the distribution type doesn't allow you to pick particle parameter, you can't drive it that way. So what happens if you smash two GPU particles together? In terms of interaction, nothing. There's no proximity checks between GPU particles to make sure that they're colliding or not colliding with each other. That can get extremely expensive to do. And there are physics solutions that specifically spend a lot of computational time on working out intra-particle collisions. The default systems that we provide do not do that. I have a base material. Is there a fancy way I could add a set of nodes to it that auto-hid anything that conflicted with my camera? If you're looking for anything closer to you than the player, so for example, if you have an isometric game where you're walking, you have an above camera looking down, and as the player moves under an arch, you want the arch to fizz away. There are a couple things you could do. There's actually a YouTube video that I did a while ago showing location-based opacity. If you do a search in the Unreal Engine channel for location-based opacity, you should be able to find it. But basically what you're doing is you're looking at the position of something in the world relative to the camera and doing a mask based on that. So as the camera moves past or over something, you have a masking value that kicks in based on the object's relative position in the world. I'd like to see how you could use blueprints in 4.9 to control tick rate on, say, characters, for example, when far from viewpoint. I know we're implementing tick groups so that you can pick different tick frequencies. I haven't done anything with it yet. I'm pretty sure it's going to be in for 4.9. I'm not positive, so I'm not going to talk much about that. Though that type of behavior is why I'm using a timer instead of the just straight up tick function. If you notice, my timer has a looping value and the particular time. If I set that to a much smaller increment, I get a much higher frequency. So now as I move in, you can see the color on the sphere changes much more smoothly. The actual results for the particle system are just going to be finer grained, but I am now executing code that much more frequently, therefore it's slightly less performant. You're not going to see that in this kind of case because you've only got a couple of assets doing anything, and there's no game code or anything running behind the scenes, so there's nothing else consuming performance. But it is something you want to be careful with, and that's the intention for having tick frequency groups, so you can set low frequency ticks to only happen occasionally. So the other thing that I was going to talk about a bit was doing traces. So a lot of times what we'll do is we need to know where something is in the world, either to spawn something when you place it in the world. So say I have a lamppost and I want to have grass around the bottom of the lamppost, and I want it to be different every time. I might, when I place it, do a trace down and maybe scatter the trace out randomly a bit to find whether or not there's valid ground near it, and then place something on it. Given that I've only got a couple minutes left, I'm not going to go through the whole thing, but what you could do, something similar to this, is having particle effects spawn in much the same way. I was playing around with a variation on the shock rifle alt-fire that had electrical arcs that went out to specific points on adjacent meshes. So as the shock ball travels in space, you see arcs come out, and rather than the way we normally do it in a particle system where we just pick a random point in space and create the particle between those, it was actually arcing two physical objects in the scene, and if it didn't find something in the trace, it would just skip that attempt and go to the next one. So it can be very, very useful to know how your blueprint can interact with the world, either by doing traces or doing things like proximity checks or even overlap checks. So if you want to know how many of something there's in the world, say for example, you have a multiplayer game and you're just doing checks to see does this overlap any number of players, you can do what's called a sphere overlap. So you can do sphere overlap actors. So now I'm looking to see what, like say, if with the sphere radius of 1,000 and where in the world is it, I can get what types of objects. So for example, pawn. So now every check I could have this look for any pawns within. So I'm now getting an array of however many players I found. So if I wanted something that was looking for more than 4 players, and if 4 players it went red, I could do something like that. And this is something you couldn't do in a material. There's no way to count the number of things that are outside of the material and then include it, except by doing something like this. So if you wanted a count of the number of things, or if you could take this much further and start integrating with UMG, where you not only get how many, but because I have an array, I can get the contents of this array and iterate through it and say, get the locations. So I could end up mapping this into a radar screen that showed me not only how many players are in my base, but map their location into some kind of material or UMG widget, and then place that somewhere where the player could see it, or it could be visible to spectators or something like that, and drive much more complicated behavior than just proximity, as I started with as an example. Let's see if there's any other questions. $1 million question. Is it possible to occlude a dynamic skylight in caves or other areas that are supposed to be completely dark? In the same vein, is it possible to make a post-process be visible from the outside? Skylights are extremely floody in that while they're on, they'll affect everything. You could, for something like a single-player game, you could easily have, based on what volume you're in, is the skylight on or off. Post-process being visible from the outside, I'm not sure exactly what the question implies. The post-process volumes themselves have a value that is the overlap radius. And how far away will this post-process start blending in? Obviously, this is based on the camera's overlap with it. So if your post-process blend radius is set to 1,000, 500 units away, if you just stand still, you'll have half of that post-process value being blended in based on priority. So it's something to know that this is a global post-process. It's set to unbound, so the radius is not in use. If I uncheck unbound, I can now set the blend radius to some value, so it's configurable that way. But you could then have something that you can overlap any number of them and have them be visible wherever you want. What's the most cost-effective way of producing convincing fog effects? Most of our fog effects tend to be really simple materials that just blend based on depth, and then we try to limit the number of them we have in a scene, because overdraw consumes fill rate, and that's your GPU performance. So we tend to be very careful with the kind of layers of that we have. Can dither temporal anti-aliasing be blurred to hide the graininess? Unfortunately, no. It actually is doing everything it can to blur itself, but that is an artifact of the way that masking versus blur is occurring. Michael Aller asked on Twitter yesterday if there's a way to totally turn off lighting for performance gains, switching to self-lit. Is there steps to do this beyond unchecking the settings in render settings? No, I believe you do have to set it in the renderer for it to work. The rendering engineers would be a better audience or a better group to ask that. Timers and timelines of frame rate dependent, correct? Is tick the only way to guarantee specific intervals? Yes, because timers just look at the delta time. So in between, it may get a very, very slightly different result of when to execute the next tick. Any news about new particle system? It's under development. It's not turned on by default in the build that we're using here. I'm sure we'll have more news in the future. Can you clip half sphere based on distance like plane clip? You can do it in the material by just doing pixel depth and feeding that into the mask and then adjusting the threshold value so that anything beyond a certain distance or closer to a certain distance would be invisible. You would have to do the correct math to adjust I think pixel depth actually gives you the half sphere rather than just a plane, whereas depth gives you depth from the plane. But I think there's a way to adjust between those. What happened to fog volumes? I love those little guys. Well, unfortunately, those little guys were an effective technique with a forward renderer. Because UE4 uses a deferred renderer, we have to choose different techniques to solve the same kinds of problems. All right, that's all my time. I hope people found it informative and at least slightly entertaining. I'm sure I'll be back to do another one of these sometime in the future, and no idea what I'll be talking about, but we'll figure that out mid-course. I'd like to thank Shelley for doing an amazing job of making me not look like a complete moron.
Thank you.
Thank you. And have a nice day, everyone.